Hey guys, welcome to the beginning of the C++ for Beginners series. In this series, we'll teach you the basics of C++, some projects, exercises, and other things that you need to know for the C++ language. Now you might be wondering what's the difference between C and C++. Well, there's a plus plus in it, and second, C++ follows object-oriented programming, where you can have classes, attributes, methods, and objects. So, my friend doing the Python series has touched upon this in his video. I'll link it in the description below. But object-oriented programming means instead of assigning a variable or an array of variables and assigning a unique value for each variable, you can have an object. Now, for example, a real world object such as a dog. Now, what does a dog do? It can eat, it can sleep, it can bark, it can play. So these functions can be implemented inside of a class, which is like a container, and these functions can be called upon by all the objects of the class dog. So each dog can have eat, sleep, play, and bark. And each object can have a different name and it can use these functions, and it can have attributes such as its name, its breed, its height, its weight. So each dog can have different names, different heights, different weights, different breeds. So let's get started. The first thing we need is an IDE, as I explained in the C series. So you can check out the IDE video of the C series because most of the IDEs in that which I explained work for C++. You just have to select the C++ option or a CPP file. And on Ubuntu and Mac, it's almost the same. For C series, we used GCC, then the file name .c. What's different for C++ is we use G++, then file name .cpp. Thanks for watching. Hey guys, welcome back to the C++ series, C++ for Beginners series. In this video, we're going to be seeing the structure of a C++ code. Now, the structure of the C++ code is exactly or 90% same to the structure of a C program code, in which it has a main function where the execution starts, header files, preprocessor directives, and a return statement if necessary. I'll put a link to that video in the description so you guys can check it out. Let me create a C++ file. Now, a unique thing in C++ is there's a structure called class. You can see the color change when I type class. If I type something else, the color changes back, which means I done it correctly. So, dog, as I gave an example in the previous video. And it has some unique words such as private, public, and protected. It also has keywords like inline, virtual, and friend. Try, catch, and throw. We will see the use of each and every one of these keywords when we get to it in future videos. Now let's see about the structure of a C++ code. The structure of a C++ code is 90% similar to the structure of a C program code, we have the preprocessor directive or the hash include, which includes libraries or files within your system. Now this IO stream has input output stream. So it has definitions, methods, variables, constants, etc., etc. And you need to include this to write C out instead. C out is similar to printf in C++, but it has much more functionality. And another thing we have is using namespace std. Now, what is a namespace? A namespace is a block of code. You can make it yourself, or std is a standard block of code which is present inside your system. And it has things like cout, endl, and other things. Using namespace std enables us to use cout in this form. If we don't have it, we have to do it like this. Now don't get confused, we'll get to what these colons are and cout these arrow marks in future videos. Next is the main function where execution starts and everything in the main function is run. So this program basically prints hi and returns a 0 upon completion or success. So let's save it, close. And you can see the output, hi. I hope you understood what I explained in this video, and I'll see you in the next video. Hey guys, welcome back to C++ for Beginners series. In this video, we're going to be seeing input and output. So the variables, the variable naming system and the number of bytes each data type holds is exactly the same as C programming, which I explained in my C series. The only new type of data type that's present is called a boolean. The data type, you type bool for boolean, then the variable name. Now boolean can only have two values, true or false. So to denote that, if it's a true, you type true with a small t, or if it's false. Now this is a new introduction in C++. Previously in C programming we were using 0 or 1 to denote true or false. Now let's do a program where we take a number input and display the output as the same number. Now in C++ we have two new methods and two new operators. To print something to the screen, we write cout. Then this is known as an insertion operator. Whatever you give after it will be displayed on the screen by the method cout. These arrow marks are known as insertion operator and they insert whatever you enter after them into cout, if that makes sense. So we'll write please enter a number, and this new keyword is known as end line and is specified by endl. Similarly in C we were writing /n. Insert this is replaced by endl or end line in C++. Now let's declare a variable. The other new method is known as cin, and this operator right arrow marks. Two right arrow marks is known as the extraction operator. So cin will extract whatever variable or number that is inserted by the user and store it here in cin. So let's write number, and now let's print the number back. You can still use printf and scanf as you did in C programming. Now let me do both. Let's enter 5. Now this please enter number is from the cout statement and the insertion operator that we did. And this please enter number is from the printf statement that we gave below cout, cin, and cout. So that is input and output in C++ programming. Thank you for watching, and I hope you understood the video. Hey guys, welcome back to C++ Programming for Beginners series. Now, as I said, C++ is 90% similar to C except for its object-oriented programming methods. So, all the operators, if-else conditions, loops such as for loops, while loops, do-while loops, switch statements, pointer declarations, defined functions, arrays, matrices, enumerations, and unions is exactly the same as C programming. So I'll link a playlist to my C programming videos in the description, and I'll see you in the next video. Hey guys, in this video we're going to be seeing about default arguments. Now in functions in C programming, you'll simply call the function with the required parameters as arguments. In C++, there's a unique feature. Suppose you have a function to add 3 numbers, but you only want to add 2. You can set the third number as 0. So if you only pass 2 numbers, the third number will automatically be equated to 0. Now let's see how that works. Now, I don't always want to add 3 numbers. I may want to add 2 numbers, or I just may want to return a single number. So I can set number 3 is equal to 0 and number 2 as well to 0. Now I can just use a return statement. In Unlike C, if a function returns a value, you don't have to store the returning value in a variable, then print or use that variable. Now with cout, we can directly just call the function and it will print the returning value. So in this, I put 1, 2, 3, 10, 20, 10 and 20, and in the last one, let me pass 100. So Let's see. The first time we call the function, we pass three parameters. So 1 will equate to number 1, 2 will equate to number 2, and 3 will equate to number 3. So the result we should get is 6, which will be printed. Then we move to the next line. This function call, we pass 10 and 20. 10 is equated to number 1, 20 is equated to number 2. But we didn't pass a third value to number 3. So automatically, number 3 will be equated to 0. So we get 10 plus 20 plus 0. And the return value should be 30. The last one, we're only passing a single number, which is 100, which is equated to number 1. Since we're not passing a second and third number, number 2 will be equated to 0, and number 3 will also be equated to 0. Hence, we should get the return value as 100, as number 1, 100 plus 0 plus 0. Let's see what happens. Oh, I forgot. So we passed 1 and 2 and 3 in the first function call, and we got back 6. Now here we passed 10 and 20. So automatically the number 3 was equated to 0, and 10 plus 20 plus 30 and 10 plus 20 plus 0 was returned, which is 30. And in the last function call, we just passed 100. So number 2 and number 3 were equated to 0. So we got 100 plus 0 plus 0. I hope you understood default arguments, and I'll see you in the next video. Hey guys, in this video, we're going to be talking about function overloading. Now, what is function overloading means, you can have a user-defined function or multiple user-defined functions with the same name, but it can differ in the data type of the parameters or the number of parameters. Let's see an example. Let's have multiple functions that add numbers, but it differs the data type of the parameters or the number of parameters, but has the same name. In the second add function, this add function takes three integer values and adds them. Since I passed only two integer values, the function call will be made to the first add function, which takes two integer parameters and returns their sum. In the next function call, I'm passing in three values, so the function call will be made to the second add function, which takes three integer numbers and returns their sum. You can see 30 and 60, which means it made function calls to two separate functions having the same name but different number of parameters. This is known as function overloading. I hope you understood function overloading. Thanks for watching the video. Hey guys, in this video we're going to be seeing about inline functions and the keyword const, or const, short for constant. Now here I have the basic C++ program structure. Now let me create an inline function. Inline, then the return type, then the function name. parameters, main function. Let me call the inline function. Now, what is an inline function? An inline function is used for small functions. So during the main function, when we call an inline function, the control passes from here to the function definition, which is here. Then the parameters are passed as the arguments we supplied, and the return value is given back to the main function and printed because of cout. Now what inline function does is instead of giving control to the function definition, then returns to the main function and prints out the inline function. This call, this function call is basically replaced by this code. Now, why is this necessary and what are the benefits? So inline functions are used for small function definitions. Hence, instead of going to the function call, go and the control passing to the function definition and back to the main function, this reduces compile time and runtime of the code, so it's more efficient. So this is basically like writing. So this add of 1 and 2 is replaced by the function definition, but instead of number 1 and number 2, it's replaced by 1 and 2. Now, let's run this code and see the output. Now you can see the output 3. So that is basically what inline functions are for. Now let's see what the constant keyword is. Now suppose you need to initialize a variable, but the value of that variable doesn't change throughout the program. You want to keep it the same. In that case, you use the word const. You can see how it's highlighted in green now. Then the return value. Now it's going to be 3.14. Here, let's try to increment the value of the constant variable. Let's save it and try to run it. It says increment of read-only variable pi, which means you can only read the value of it. You can't write to it or change the value of it because it's declared as a constant. Now let's try doing that again, but when we remove it. We remove the constant keyword. See, now it works because it's not a constant unit anymore. You can manipulate the value of the variable however you like. So that was constant. I hope you understood inline functions and constant variables. Thanks for watching. Hey guys, in this video, we're going to be starting with object-oriented programming concepts. Now, what is object-oriented programming? Instead of using functions and variables like we usually do in C, we consider data and functions as objects and classes. Now, what is an object? An object can be any real-world item, such as an animal, a shape, a car, a human, a bed, etc., etc. So these are objects. Now, what is a class? A class defines how an object can behave and what data that object has. Now, classes include two things: attributes or data members and methods or member functions. Attributes is basically variables or things that can hold data. Suppose if I take a car as an example, its attribute can be color, weight, brand, height, speed, maximum speed. This is also known as data members. Now what are methods or member functions? Methods are basically functions that defines what an object can do. If I take the example of a car again, it can be start the car, stop the car, turn right, turn left, accelerate, brake, reverse, etc., etc. Now, my friend who's doing the Python series has done an explanation on this. I'll link his video in the description. Now, how do you define a class, an object in C++? So use the keyword class, then whatever class name you want. Now suppose, as I was giving examples as car, I'll name it a car class. Now below that, as I said, classes have data members and or attributes, and methods or member functions. So the attributes is the color. So if I say string color is equal to, or I can just keep it as color, then float weight string brand. Now up here I'm putting public. I'll explain that in future videos. Now these three things can be the attributes or data members. Next we have member functions or methods. So I said to turn right, so and at the end of the class definition there should be a semicolon. Now in the main function we need objects of this car class. So how do we define objects? Objects are done by telling the class name, then the object name. It can be any name you want. Suppose I put car1. I can set the data members or attributes of an object, and each object has its own value or own copy of these attributes. Now I can make multiple objects. I made 3 objects of the class car. Now I'm going to set the color of them. Each of them is going to be different. So now how do we access these attributes? You use a dot, then the attribute name. Now let me print out each of these colors to show you that each object has its own copy or its own value for the data member, and they don't connect or they don't share a single copy of that attribute. Let me also include the header file string. Let me save it and run the program. Now you can see I created 3 objects of the class car, and I set different colors to each object. So I printed them And as you can see, each object of the class car has a different color. So each object has its own set of attributes and data members, and they're not associated with each other. Now let me call member functions for each of them. Now let me call the member functions for each object. Now I told two cars to turn left and one car to turn right. And there you go. I hope you understood classes and objects, and please refer to my friend's video in Python explaining the same concepts. It doesn't matter which language you're learning, the concepts and logic usually remain same. Thanks for watching. Hey guys, in this video we're going to be learning about constructors and destructors and types of constructors. A constructor is usually called when creating an object of the class. A constructor has the same name as the class name, but it's a function. A constructor can have parameters, and there's three types of constructors: default constructors, parameterized constructors, and copy constructors. Now, what is a destructor? A destructor is called when the program ends at the end of the program where the objects of the class are freed in memory or they are deallocated. So they usually delete the object of the class when the program ends. So I'll take the same example from last time, class car. Now, let's create a constructor. Remember, a constructor has the same name as the class. So car constructor called. Now let me only create one object of the class car so we don't get confused. You can see the constructor was called, but I didn't make any actual function calls in the main function to the constructor. It's automatically called when you create an object of a class. Now let's call a destructor. A destructor is also a function, but it's called at the end of the program when your object is destroyed. So it has the same name as the class name, but it is preceded with a tilde. Now let's run our program. So you can see constructor is called, then when the program terminates, the destructor is called. Now a destructor cannot have any parameters since the object is getting deleted anyway, so it's of no use. Now let's see the types of constructors. A class can have multiple constructors. It's called constructor overloading, similar to function overloading. The same constructor name but with different parameters, different type of parameters, or a different number of parameters. Now, the constructor we used is known as default constructor. It has no parameters and it's called even if you don't define it. Since we didn't create a constructor, it doesn't mean that a constructor is not called. When an object is created, a constructor is called by default, no matter what. Now let's see the second type of constructor. The second type of constructor is known as parameterized constructor because it has parameters. Suppose I want to set the color and the brand of the car. As soon as I call it, I can pass in two strings. So string color parameter. Within this, I want to set the color to the color parameter. Now when I create the object in main function, I can pass those two. So red and Toyota. Now let me print these to show that the constructor set these values. And you can see red, Toyota, which is the values we set when we initialized or created the object, then the destructor is called. Now let's see the third type of constructor. Now the third type of constructor is called a copy constructor because it copies the attributes of one object to another. Now suppose I created here car of car 1. Let me first create the constructor or the copy constructor. So car, so I'm passing in an object of the same class, of class car. So car uh, object. Now the color of this object is equal to the color of the car object. And similarly, brand of this object is equal to the brand of the object that's passed as an argument. Now let me create another object of class car2, and let me pass car1 as the argument. Now let me print car2's color and brand so that we know if car1's attributes have been copied to car2 or not. And when you pass an object as an argument, you always have to pass the address of an object because object is not a single value like an integer. You can see here we're printing car2's attributes, where in car2's constructor we passed car1 as the argument. So it has been copied. Car2's color is red and car2's brand is Toyota. Now why do we have destructor called two times? Because at the end of the program it needs to deallocate or destroy two objects, car1 and car2. So this is printed from car1's destructor and this is printed from car2's destructor. This also shows that the class can have multiple constructors and is known as constructor overloading. I hope you understood the video. Thanks for watching. Hey guys, in this video we're gonna make a game using objects and classes. So basically we're gonna create a car class and we can be able to navigate, we can control the car using member functions, and a repeating menu. So basically, you can move the car, but only if it's on. And if you want to exit the game, you still you have to and if you want to exit the game, you have to turn off the car. So let's create a boolean value to check if the car is on. Let's set it to false initially. Then we need a bunch of member functions to operate the car. Now in the turn on member function, we're just turning on the car. Basically, turning on the car is setting the is on boolean value to true. But we have to also check if it's already on. We can't turn it on twice. Else we turn it on. Now we need to turn left, right, accelerate, or reverse. So four functions. Here also we have to check if the car is on or off. So if it's off, we have to tell them to turn it on. Else we can turn right. Let's include a message here also telling that it has been turned on. Now turn left is exactly the same as turn right. The last one is turning off the car. So if is on is equal to false, we say car is already turned off. Else we make is on is equal to false. Now we get to the main function. To create a repeating menu, we have to use a loop. First, we just create an object, which is car1. Then we make a user input, which is an integer input. And let's just set it to 0 for now. Now while eat, here let's create our visible menu. So this while loop condition should be not equal to 7. Now after, okay, ENDO. After this, we have to take the user input from the user. So we'll just use a bunch of if conditions, or actually case will be much more useful. So let's switch user input and then case 1 car1 dot turn on. Seven. Let's make it so they can only exit the program if the car is turned off. So if car1 dot is on is equal to false, break else see out, the car is still on. ENDL break default see out invalid input ENDL. And we have our menu. Let's try to navigate the car without turning it on. So 2, car is not turned on. 3, car is not turned on. Now turn on the car, car turned on. 2, turning right, turning left. 7, I can't see the output. The car is still on, so we left. And that's how you make the game, a car game using classes, objects, data members, member functions, and a repeating menu. I hope you understood the video. Thanks for watching. Now C++ is an object-oriented program. So in previous videos, we saw what were classes and what were objects. Now suppose an object of a class also resembles objects of other classes. For example, the most common or in class example, they use animals. Suppose there's a class called animals. It's a general class describing functions that all animals use. But suppose there's another class called dog, a class called fish, a class called cat. Now, even though they're specific classes, they describe what dogs do, fishes do, and cats do, they also fall under animals, and they also use the common functions that are described in the class animals. Another example is shapes. Now there's a common class called shapes which has functions and attributes that all shapes have. But there are other classes called circle, rectangle, square, which are more specific, but they also fall under shapes. So they can also use the attributes and functions defined in the class shapes. Now let's see the animal example and how inheritance works. Inheritance basically allows the specific classes to use the functions and attributes mentioned in the more generalized class. Now the more generalized class or the class in which the functions and attributes are used by the specific classes is known as the base class. And the classes that inherit these properties or use the properties defined in those general classes is known as a derived class. Let me take the example, which is animals. Now, let me define an empty class called dog. Now, in order for an object of class dog to use the speak function which is defined in the class animal, it has to inherit the class animal. So how inheritance works is in the base class, in the derived class, you put a colon next to the name and public, whatever access specifier you need to use, and the base class name. Now this denotes that the class dog inherits all the public access specifier attributes and methods from the class animal. Now let's call that function, and it says animal speaks. Now let's remove the inheritance. So if we remove this public animal, no longer it means that the class dog is no longer inheriting the class animal. So let's save it and see what happens. See, class dog has no member named speak because it's an empty class which is not inheriting anything from the class animal. So that's about inheritance. I hope you understood the video. Thanks for watching. Hey guys, in the last video we saw about inheritance. Now we'll see what happens to the constructors if there's inheritance and how to pass arguments from the derived constructor to the base constructor. Previously we saw these two classes, so let's work with that. Now an animal, suppose it needs a name. If there's no parameterized or copy constructors, then there's no need to pass arguments or to define constructors at all. But suppose it needs parameters such as an object or other items. Let's see how that works. But in class dog, there's no constructor, but the animal class has a constructor and it needs a parameter. So how do we pass that? We define a constructor here and colon, then we call the animal constructor and pass the name like this. Now here we have to pass the argument. Let's say Henry. And we also have to add back the inheritance. can see it says Henry speaks instead of animal speaks because Henry is a parameter that we passed to the base class through the derived class. I hope you understood the video. Thanks for watching. Hey guys, in this video we're going to be seeing exception handling in C++. Now exception handling is when you can't run the program due to an exception. We've seen errors when compiling the program. Those are basically exceptions. So instead of getting those errors, you can create situations to handle those errors. Those are known as exceptions. Now let's see a simple error and how to handle it using exception handling. Now suppose I do cout 0 by 0 endl return 0. Now suppose I make a variable called result, which is equal to 0 by 0 by 0, and print the result. Save it and see what happens. It has a warning called division by 0, which is an error. Let's run it. And we have floating point exception core dumped. Let's see how to handle that exception. In exception handling, there are three keywords which are used: try, catch, and throw. Now let me show how to use each of them. Let me use a try word. Try word tries the block of code that follows it, and if there is an error, it won't display it. You can do a catch to throw that error in the try block. Let me do if b is equal to 0. You can throw anything for an error. Let me throw 5. If it's not equal to 0, we'll do else cout and print 5 by b. Now what this try and throw block is, it the code below the try block is run. So when b is equal to 0, it throws 5 and the execution of the try block stops. Otherwise, it runs this else part, and if there's no errors, the try block is complete and it's executed. If there is an error, the try block is stopped. Now after this, it's usually followed by a catch block. And here you can catch anything. Just mention the data type. Since I'm throwing 5, which is an integer, I'll catch an int a. If this is caught, you can give your own custom error message, such as cannot divide by 0. Suppose I threw a, here I would catch a character. Suppose I threw a string, in the catch block I would catch a string. I can throw any integer. It doesn't have to be 5. I can throw 1, I can throw 0, I can throw 33, anything. It just has to be an integer. Now, let's save the code and see what happens. And you can see our custom error message cannot divide by 0, whereas previously it said divide by 0 error. And that is known as exception handling and how you use try, catch, and throw statements. I hope you understood the video. Thanks for watching. Hey guys, in this video we're going to be seeing about the friend keyword and how to use it. So the friend keyword enables functions and classes to access the data members and member functions of another class. So let me declare a class with some data members and member functions. This doesn't even have to be public. Using the friend function, we can also access the private and protected data members and member functions. Now, this data member data member is set to 0 and is private. And same thing with the member function hello. Now, before we move on, we have to declare that the functions sample and the class another class are friends. Now let's declare the sample function and let's declare the class another class. Which will display the data member value of class example. Now let's get into the main function. Declare an object of class example. Declare a class of another class. Hello. Now let's call the function sample and pass the object of example. Next, Let's call the member function of another example, which in turn uses the data member, which is private, of class example. There we can see the member function hello and the data member value. I hope you understood, friend class. Thanks for watching.